So, regarding the sacrificial layer, I mean, Cebu's thing, what is doing? We have two things here. One is that if for whatever reason you realize that you haven't put a sacrificial layer and you have a technique for not crashing against the bed, like Cebu is doing, I mean, this is perfectly valid and okay. But doing this as a common practice in a place where you are not the only one using the machine, I mean, this is not okay. This is why you don't have 132 bits and 164 bits. Well, no, 134, 164 is not the reason. But 132, this is the reason you crash against the bed all the time.
But nobody, like, so far only Cebu has used it for his experiments, and then one of us just did that as a mistake. So nobody used that kind of approach except for Cebu, and somebody did a mistake. That's all.
Yeah, but I cannot imagine, I mean, 164 bits you can break, but I cannot imagine how can you break a 132 bit.
Yeah, I'm also surprised actually.
Even we can imagine.
I don't know where they all went. I have the count for how many bits were there during pre-academy.
I think I only have one. I mean, I have 3, but I have only used one since 2013. And with all the students, has been like 8 students, and me using it a lot. It haven't been broken.
Super.
So how many of these do you have broken?
Let me check how many we had during pre-academy.
You have like 10.
164th we have around 10 of them.
By the way, Jasil, did you complete the accelerometer? Did you mill the accelerometer, Jasil?
Jasil, you do the accelerometer.
Yeah, it's working.
It seems it's working. He has done it.
Did you solder it?
No. I use the external accelerometer, not the from Fabacademy.
No, he used an external accelerometer. Not the. Did he solder it?
It's a module.
Yeah, it's an external module. He didn't do it. He didn't solder it and all. He got the readings from it. That's what he's saying.
Did you document that in your page?
No. I documented
he hasn't yet.
And it was an I2C accelerometer, isn't it?
Yeah, I can say excellent.
And were you were you using 85?
What? 85?
80 times?
80 times.
89 is 85. 45.
Yeah, he was using 45.
With I2C?
Yeah.
Mm-hmm.
Francisco, I referred Neil's ADXL 335 board.
Sorry?
I referred Neil's ADXL 335 board.
No, the problem is the echo cancelling
No, he's
circuit of the microphone.
not
If
close.
you are not close enough,
Okay.
doesn't get you.
Francisco,
Yes?
I use
Better.
Neil's IDXL 335 board for reference.
Okay. And are you getting the raw data or are you getting the interrupt data?
Raw data.
The raw data.
Yeah.
Did you hook the interrupt to any pin?
No. I used only SDA and SCL pins only.
Okay. But I recommend you as well that you always, when you have one of these sensors, that you always hook the interrupt pins to the microcontroller, because these interrupt pins, they can save you a lot of coding. If you want to detect when the acceleration is 0 or when it's it has some built-in features that are very important that you hook them to the microcontroller. For example, in my case, for detecting CO2 in a sensor, they have the readings, okay? So I can display the readings of the CO2, but then if the level is above 700, it has to display in lead certification, it has to display a visual alarm. And then if the level of CO2 is above 1,400 ppm, it has to display an acoustic alarm. So I can do this in the code because I'm getting the readings, but I never do this. I just hook the interrupt points that has 700 and 1,400 to the microcontroller, and when the signal is high in this, trigger an interrupt that triggers the alarm.
Okay.
So it simplifies a lot the code you are going to use. Now maybe for what you are doing, you don't care, but say you are making a drone, you cannot waste even a single cycle.
Okay.
If you are making a drone, you cannot waste not even a simple cycle of the microcontroller doing things that an interrupt pin can do.
Okay.
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 So I want to see your documentation. Very nice that you could make it good.
Okay, sure.
And what are you using to display? Are you using Nil program or you are showing data in raw?
Using Neil's program. Using Neil's program, Python code.
Okay. Okay. And use Rashid.
Yeah, Rashid.
Rashid,
Yeah, yeah.
what are you doing for input devices?
Actually, I am doing using IR LEDs.
IR LEDs
Uh,
and phototransistors.
yeah, photo transistors.
Okay, but Rashid is the same board as Neil is using, or you are modifying it in some way? You get it?
No, Francisco, not clear.
If you are designing your own board,
Yeah, yeah, I am designing a board.
okay. What I recommend you to do is to modify this board to add it has an IR LED,
Yeah,
an
yeah.
IR phototransistor, and then you add a normal LED. So instead of showing like in Neil's code, when you are closer,
Okay.
it it sends a signal. You can modify the code through so you do PWM on the pin.
Oh, okay.
So the light goes bigger, like brighter when you put the hand closer. It's a good
Okay.
modification.
Okay.
Now, let me check. Okay. So for today, what you should have at least is the oh, I'm not sharing my screen. Let me check. I'm gonna share my screen. You have the bags over there, Puneet.
Need-
Do you have the bags over there?
Yeah, wax we have.
Okay. Today, an email has been sent to the class. I recommend you with a tutorial. I recommend you to watch it. Very nice, from Saverio Silli from Italy, about molding and casting. I recommend you to watch it. It's going to be very interesting.
Okay.
Then he recommends one thing that I also recommend
Uh-huh.
is that once you have your block of wax with your thing here, he is getting a brush
Okay.
and he's brushing all the surface first.
Brushing the surface.
Yeah, with the silicone.
Okay.
So you first brush, and you make sure that the brush gets inside the fine details. Because if you try to pour, like if there is something like this very fine, things like this. If you pour, like, it's very difficult for the
Yeah.
for very very
Yeah.
fine layer get into these
Yeah.
cavities. So what he's doing is with the brush, he's applying a very fine layer. Well, this could not be done, but very fine layer to all the surface. So he guarantees that the surface, at least, there are no bubbles in the surface.
Yeah.
So
I've done
maybe there are
yeah. I've done
little
a lot of
bubbles.
I've done a lot of molding and casting for like the people who want to use. They come like for clients and all. At that time, I followed all these instructions actually. Uh,
Okay,
I,
very
I
good.
initially applied a thin layer so that there is also to avoid bubbles on the surface. I made a very thin layer of silicone first on the surface, and then I poured the rest of the silicone.
Hmm. That's a very good practice.
Yeah, Neil says we like making a very thin bead of the silicone will the bubbles will get popped up before it reaches the the cavity. But I find that when it reaches that thin bead, when it reaches the surface, it kind of stacks up like a solid. At that point, it starts that is not a very good thing. So it's not very easy to get the bubbles
Yeah,
out.
Neil doesn't like, but you know what happens? That I think Neil has everything correct, meaning all his umu and whatever things he's using, they're up to date. But most of the people on the labs, we are dealing with things that are not as good as that. I mean, they are maybe
But
1 year old.
I can't imagine the difference in viscosity to achieve that. You can never, almost never achieve a no bubble or a very less bubble silicone molding. Sorry, casting.
Hmm. Yeah.
Mold Max 60 is pretty lightly viscous, so it doesn't like there are no bubbles. But at least the 37 clear that has a lot that gives a lot of bubbles. So only
Okay.
way to remove them is like vacuum degassing.
And this is one thing. Then let me talk about the vacuum.
Yeah.
Hmm. What you need to have is something like rigid. You need a rigid plate, like could be one of the plywoods that you have with holes. You have done something to the plywood, but not many holes. I mean, has to be some structural strength here, or maybe a new one that you only use for this, or could be a piece of whatever, but a plate, something rigid like plywood, not the one from the shop, but the one for the laser. Then you grab this and you hit the corners against the floor, so the corners become, instead of sharp like this, they become a little bit like this. Okay, you hit this to the ground, in every 4 corners. You get a rounded surface
Wax.
here.
All these are wax.
Sorry?
These are the, you mean we should do this for the wax?
No. I'm talking now about this is a piece of plywood.
Yeah.
I think they are 60 by 30, more or less. You get this 60 by 30 plywood to make the corners round,
Okay,
like
got that.
hitting to the ground. This is because you are going to put the wax blocks inside this. You will put all your wax blocks inside here, and this whole plate will be inside the vacuum bag. Okay.
Okay.
So for this plate not to break the bag, you need to round the corners, because otherwise the force of the vacuum will
Yeah.
break the bag.
Yeah, I get it. But this is a plywood box?
No, it's a plywood
Plank.
plate.
Plate.
Plank,
Okay.
yeah. It's the 3mm thick one.
Okay.
It is just for support, because if you can do it without this, theoretically, but if you don't have an even surface, this might be stay flat or not. And you don't want. When if, say this is the back now, it's if the air that is coming in like this, if you put just the things here, the whole thing, depending on how this is like this,
Yeah, I understand.
when you apply vacuum, it might end up like this. Like the back is not.
Yeah, yeah.
So that is why below these blocks you put this flat surface. So when you apply vacuum, everything is going to be like this.
Okay. Doesn't the silicone expand during vacuuming?
Yeah. Now, what you have to do, it doesn't expand, but the bubbles come out. And you will see at the beginning something like this.
Yeah.
But with the force of this, it's not going to be like this. It's not going to be leaving the other part.
Okay.
So the other thing is you cannot allow the bag to touch the silicone, because otherwise it will be a one-use bag. Okay, so what I want you to do is you have here your plank, you have here your blocks of wax with the silicone in here, okay? And then I want you to put like maybe some blocks of wood or whatever you want to put. And then what we use here it
Can we
catches.
can we place the wax together? Nothing in between, like close, compact.
What do you mean together?
All the wax together, like nothing in between. Those black things, nothing. Those wood blocks are not required. All the wax are together.
Yes, you can. If you find, you need. I'm doing it like this because you need to find, like, here we use an acrylic
Okay.
an acrylic cover like this. But if you put them together, you can find, you put all the blocks together, and you can find something big enough to cover them all. It's okay.
Okay.
In fact, we have one of these bigger, and we put 3 of these in one. But for the rest, we put them separate. Or you put it like this and do it in. So the thing is, you put this on the back. Say you put it like this, like you said. What are you going to use for that? For this black layer?
The cover.
You can use like cooking.
Utensil. Oh.
Yeah, cooking whatever,
Yeah.
stainless steel.
Yeah. Yeah.
Has to be something that doesn't have any sharp feature on it. Can be like this. The only problem with this is that you cover it and you don't see the result.
Hmm. You have
Also,
to leave some vents.
yeah, it is very important the following. Say you have these 3 blocks here, your surface in the back here. It is very important one thing. You don't put this thing like this, because that way the air doesn't go out.
Hmm.
You need to put like small, even whatever that is small, like small circles of acrylic. It's more like coins of acrylic
Yeah.
beneath this, so the air can go out.
I think the best is the bleeder cloth.
No, the bleeder, no, is not good, because the pressure that is going to be applied, I don't think and the weight of this is going to press the bleeder that very much. I don't know if all the air is going to be leaving.
Okay, so the bleeder will get pressed, you mean?
Yes. I
Okay.
don't know by how much. Maybe it works, but I recommend you that you have space for the air going out all the time.
Okay.
Then how this thing works is like the following. You have here your industrial vacuum cleaner.
Hmm.
And you have here the diameter of the box. You have to 3D print something to do like this. You have to 3D print this adapter. Like this is made for household vacuum cleaners. But you have an industrial vacuum cleaner. First, you have to check that this is the thing with the cover. Your vacuum cleaner fits on this or not? Do you know what I'm talking about?
What is this? What is this? I don't understand.
I
Oh, the
mean,
cap. The cap. Yeah, yeah, yeah,
yeah, the cap and your vacuum cleaner.
yeah.
Does it fit inside?
No, it's much bigger. I haven't tried actually.
Okay.
Let's see.
Much.
I'll just go check.
Does it come with an adapter?
Okay, yeah.
Okay, let me check what you are doing. Good morning, Akshay.
Good morning, friends. Hello?
Hello.
Yeah, Frank.
How are you doing?
Nothing. I just come to lab.
Akshay, what
Yeah.
are you doing for input devices?
I'm thinking for water level sensor
Uh-huh.
for my bucket.
Where are you getting this water level sensor from?
Yeah, I will buy it from market.
Okay. This is an analog or digital sensor?
I mean, first I have to which whatever I will find it easily, so I will try with that.
Yeah, but I mean, if it's an analog or digital sensor, do you know? Do you have the datasheet?
Yeah, I have.
Okay.
Hello?
So let's see. If they come back with the back. So,
Yeah.
Akshay,
Yeah, friends.
for today you had to decide a design for the molding and casting. You
Yeah.
know what are
Sure.
you going to do?
Yeah, I know a little bit about molding and casting. Luciano told us once.
Ah, Luciano.
Yeah,
Ah, Luciano will set up this Fab Lab, isn't it?
yeah, Luciano, Bass, and Sally, and Sherry.
And who Sherry as well?
Uh, First Luciano, Bass, and Sally comes.
Yes?
Sally from Robot.
Yes, Sally from Turbot.
Then after 2 days, Sherry comes here.
Okay.
Yeah, but mostly Luciano and Bass set the lab.
Okay, okay.
Most of the part they done.
Okay.
Hmm.
So you did molding and casting there?
Yeah, at one time I seen just means I know I have a one brief idea about that.
No. Yogesh?
Sorry,
Yogesh?
Yogesh he don't know, so I will explain him. We done
Mhm.
up to the Babbit material. We have the Babbit also here.
Uh, are you doing something on Sunday? Because I think Pranya told me.
No, actually, me and Yogesh think that we will start Sunday morning. We will go to the Pabal,
Mm-hmm.
but unfortunately, Yogesh had some work, and I have also my passport police verification. So we didn't went today. So tomorrow morning we are leaving from here. I guess tomorrow Sunday until the Monday first half we will complete the whole machine assignment. We're done with everything. Prashant is looking for software kind of software things and programming. We
Yes.
get all we get all the equipments, belts, pulleys, everything. We just have to assemble it.
Okay.
So tomorrow until afternoon, me and Yogesh will reach to the Pabal. Then we will assemble it. I guess in Sunday we will complete it totally.
Okay.
About structure and all, Supriya is doing the design and she done the cutting and all things.
Okay.
But the thing is, stepper motors, timing belt, and pulleys we have with us, with me and Yogesh. So we will get it tomorrow. Means we have with us. So we are getting, we are going there tomorrow. So we will assemble it. Yes.
Okay.
Hmm. And we will talk on Sunday. Yeah, sure. We both will be there only.
Okay. You told me to go.
Yeah.
So for molding and casting, watch closely. You need this back also, Akshay. Neil says not, but I tell you, you will need this if you want to do good things. So yes, this is the back, and you open the cover like the
That is clear.
yeah. This you put the plate inside. Okay. You make sure that the silicone doesn't touch. It's not going to touch when you apply vacuum. And then you reclose this. You reseal the back. And where's your vacuum cleaner?
Trivandrum. Talking to Trivandrum.
Yeah. Puneet, do you have the vacuum cleaner around?
Yeah, yeah.
So get the vacuum cleaner and get the caliper.
I have
Okay.
the attachment.
So does it fit?
No, it doesn't.
So one side is too small,
Yeah, too small. Either too small or too big. Yeah.
but the other side fits in the industrial vacuum cleaner.
Which other side? Yeah, this other side. It has.
This is the size of the industrial vacuum cleaner.
Yeah, and it goes like this. It covers everything.
Okay. So what you are going to do is one thing. You are going to design and 3D print a cone similar to this,
Okay.
but in one side is the same as this that goes to the vacuum cleaner industrial, and the
Yeah.
other side is it goes to the vacuum cleaner bag,
Yeah.
and you put it to 3D print. Doesn't have to be very long, like
Yeah. 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 I know.
like 3-4 centimeters
Okay.
tall, not very long. But make sure it lasts for a long time. So make it solid plastic, and make it thick enough, like you are seeing there, thick enough that it's going to be resistant.
Fine.
Okay, it resists over time. And maybe you want to do something like this. Um, Instead of doing one cone like this, maybe you want to do something like this. Okay, so this goes into the
Right.
vacuum bag, and this goes to the industrial cleaner. Make sure that you measure this correctly in the vacuuming,
Yeah. I do.
so it can enter. And if you want to find failure, don't do it like this. So make a little bit of chamfer, so it goes better inside.
Okay.
Okay, like this.
Okay, like that.
In the inside of this as well, if you want.
So that might go to outside the wall, right?
Sorry, hold a second.
Yeah.
Akshay, can you mute? Because you are getting echo.
Yeah.
Okay. Sorry, second.
Yeah. So there is a outside wall and an inside wall. Uh, so there is a small. So the one you
No, you
show
go in the inside wall.
inside wall.
Yes,
Okay.
because you don't have to apply vacuum all the time.
Hmm.
Okay, what you are going to do is you apply vacuum until you get enough vacuum inside, and then you close the tap. You close
Okay.
this thing, the cover, the cap. Oh, is the cap?
Actually, there is yeah, there is a cap. Small cap.
Yeah. When there is enough vacuum, you close the cap, and the vacuum that is inside is gonna be removing the bubbles all the time, even if you are done, are not you vacuum anymore.
Okay.
So the only thing you are doing is removing the air from inside, and you close this cap. This already has a valve, so the air can go out but cannot go in. But still, you put the cap for extra security.
Yeah. Okay. Yeah, this can be done. I'll figure it out.
Okay. Hold a second. Okay, I'm back. In. Okay. So I think this is all. I mean, I want to leave you working on that,
Yeah.
and I'm gonna stay over here, like reviewing your stuff, your weeks. So if you need something, I'll be around. Call me in River.
Yeah.
Okay.
Yeah. See.
See you later then.
Bye.
Bye.
So, Akshay.